Welcome to section 2.4, the derivative. Our goal today is to find the first derivative of a function using the four-step process. We'll start by talking about our average rate of change. This is most commonly known as our slope, but we're taking the average over time. So we have values of a for one value of x, and then we'll do a plus h for our second value of x, which just means we started at 1x and we added a difference, we moved a difference of h. And these are our two x values, which means here's our x's and we take the difference of them, right? Rise over run, change of y over change in x. This is the change in x on the bottom, which means on the top, f of a plus h is the y value at that x, and f of a is the y value at that. So we have the difference of y's over the difference of x's, which we are familiar with. And if we look at simplifying this, we notice that we have a plus h minus a. So we're just going to be left with h. So really, as long as h isn't 0, our formula for the average rate of change is our y value at a plus h minus the y value at x, all over that change that we made, the difference in our x values, so h. And we'll use that a little bit today. Remember, h represents our change from our initial value of x to our final value of x, so that's the difference. Then we have instantaneous rate of change, and the instantaneous rate of change is just our rate at x. So if at one point, we want to know what's the slope at that point, and what we do is we take the limit as our h goes to 0. What does that mean? That means we're making our change from one x to another closer and closer and closer to 0. So that way we have no change. We're looking at just one specific little point. So I always like to imagine, okay, I have some function and I'm only interested in one point. So if I'm looking at the rate at that one point, I'm interested in the slope that includes only that one point. The slope of a line that includes only that one point, not 2 points. So before, I guess I should have included a visual. If I had a function, my average rate of change would be like, okay, from here to here, what was the average change? So we're looking at the change that includes those 2 points. And we just labeled the difference from here to here is h on our x. So we moved a value of h. Here, down here, we have an instantaneous rate. It's only looking at the one point, and we want to know the rate at that point. So we're taking the limit of the average rate, but we're making our change closer and closer and closer to 0. We're making our h go to 0. And this formula is also used to find the slope of a graph at a point a, f of a, and to find the first derivative, f prime. And that is what we're interested in today. So here's our procedure for finding the first derivative. Number 1, find f of x plus h. So we want to know what is our y value at this x plus h that we're looking at. And then we subtract off the original y value, f of x. So that takes care of our numerator. Then we put all of that over h, the difference, how far we moved from one x to the other. And last, we take the limit as h goes to 0 of this function that we have found. So our 4 steps are really just breaking it down, following our order of operations. Okay, let's take a look. In problems 1 through 3, use the 4-step procedure to find f prime Then find f prime of 1, f prime of 2, and f prime of 3. So we're finding our first derivative, and then we're going to plug values into our derivative and see what comes out. So we have f of x equals 9x plus 4. So first, we're going to find f of x plus h. And everywhere I see an x, I'm going to turn it into x plus h. So I have 9x plus h plus 4. And what I'm going to do is distribute. So I'm going to rewrite 9x plus 9h plus 4. We don't have any like terms, so I'm going to continue to step 2. And we take f of x plus h, and we subtract off the original f of x. So my f of x plus h was 9x plus 9h plus 4, and I'm going to subtract my original f of x. So I'm going to put it in parentheses because I'm subtracting the whole thing. 9x plus 4. And the first thing I do is distribute that negative out so that way I don't forget that anybody has a negative. 9x plus 9h plus 4 minus 9x minus 4, which is really nice because 9x minus 9x, 4 minus 4. So we're left with 9h. So that's pretty cool. Step 3, we do f of x plus h minus f of x over h. So we're going to divide it by h. So we ended up with a 9h. We'll divide by h. H over h cancel, and we're left with 9. And our final step, step 4, is take the limit as h goes to 0 of this guy that you've been working on. So this is the limit as h goes to 0 of 9, and no matter what h is, we're always going to have 9. So now let's call that, I'm going to say f prime of x is 9. And now we want to find f prime of 1. So f prime of 1, well, if I plug in a 1, I'm still going to get out a 9. If I plug in a 2, f prime of 2, I'm still going to get out a 9. And if I plug in a 3, f prime of 3, I'm still going to get out a 9. So we've got 9s. Okay, let's do it again. F of x equals negative 2x squared plus 4x minus 7. Step 1, f of x plus h. So everywhere we see x, let's turn it into x plus h. Minus 2 parentheses, because the whole thing's being squared, x plus h squared plus 4 x plus h minus 7. Okay, now I'm going to square, so negative 2 x squared plus 2xh plus h squared, and distribute 4x plus 4h minus 7. And then let's distribute the negative 2. Negative 2x squared minus 4xh minus 2h squared plus 4x plus 4h minus 7. I do not see any like terms. Step 2. F of x plus h minus f of x. So negative 2x squared minus 4xh minus 2h squared plus 4x plus 4h minus 7, and we subtract our original. Negative 2x squared plus 4x minus 7. Okay, like I did last time, I'm going to distribute the negative sign first. Negative 2x squared minus 4xh minus 2h squared plus 4x plus 4h minus 7 plus 2x squared minus 4x plus 7. Can anything cancel? So negative 2x squared, positive 2x squared, positive 4x, negative 4x, negative 7, positive 7. My favorite part. Okay, negative 2h squared plus 4h minus 4xh. That looks like all of it. Next, step 3, we'll divide everything by h. So negative 2h squared plus 4h minus 4xh over h. One of those, one of those, one of those, one of those. Everything loses an h. Negative 2h plus 4 minus 4x. And then you take the limit as h goes to 0. So we have the limit as h goes to 0, negative 2h plus 4 minus 4x. So h is going to 0, which is going to leave us with 4 minus 4x. So that means f prime of x equals 4 minus 4x. And if we plug in a 1, we get 4 minus 4. So we get a 0. And if we plug in a 2, we get 4 minus 8, negative 4. And if we plug in a 3, we get 4 minus 12, so negative 8. And that's what we've got. We found our first derivative and we found values of our first derivative. So very exciting. Okay, number 3, f of x equals 2x over x minus 5. F of x plus h. 2 x plus h, x plus h minus 5. So let's distribute. We'll do 2x plus 2h over x plus h minus 5. Next, subtract our original. Two x plus 2h over x plus h minus 5 minus 2x over x minus 5. And in order to subtract fractions, we need common denominators. So what I'm going to do is multiply each of them by the other one's denominator. That way they're the same. So I'm going to have 2x plus 2h over x plus h minus 5 being multiplied by x minus 5 over x minus 5. And then I'm going to have 2x over x minus 5 being multiplied by x plus h minus 5 over x plus h minus 5. Okay, a couple of things. This is going to make sure that our denominators are the same. And also, we need to multiply the numerator and denominator by the same thing because this has a value of 1. Anything divided by itself is 1. So we're not changing the value of anything, but we are making sure that we have common denominators. So if we multiply these things out and subtract, looks like we'll have 2x squared minus 10x plus 2xh minus 10h, and then we've got minus 2x squared minus 2xh plus 10x over x plus h minus 5 times x minus 5. I'm going to just leave that in factored form for now. Let's see if anything will cancel. 2x squared, negative 2x squared. 2xh, negative 2xh. Negative 10x, positive 10x. All right, so we've got negative 10h over x plus h minus 5 times x minus 5. Okay. Next, we need to divide by h. So we've got negative 10h over x plus h minus 5, x minus 5. And we have a division of h. And so h's cancel, and we've got negative 10 over x plus h minus 5 times x minus 5. And last, we take the limit as h goes to 0. And when h goes to 0, we have negative 10 over x minus 5 times x minus 5. So x minus 5 squared. So we will write f prime of x equals negative 10 over x minus 5 squared. Now let's plug in f prime of 1, negative 10 over 1 minus 5 squared. So we've got negative 4 squared, negative 10 over 16, we can reduce to negative 5 over 8. F prime of 2, negative 10 over 2 minus 5 squared. So we've got negative 3 squared over 9. That's going to stay. F prime of 3, negative 10 over 3 minus 5 squared, negative 2 squared, negative 10 over 4, negative 5 over 2. And so we have our derivative and values of our derivative. Next up, we are going to look at an application. The profit in hundreds of dollars from the sale of X items is given by P of X equals X squared plus 5X minus 3. Find the average rate of change of profit from X equals 2 to X equals 4. Find the instantaneous rate of change equation using our 4-step procedure. And then, using the equation found in part B, find the instantaneous rate of change when X equals 2. And interpret. So we need to tell what it means in terms of the problem. Okay, let's start. Find the average rate of change of profit from X equals 2 to X equals 4. So first, we need to find what are our values, what are our Y values, or in this case, what are the P of X values at 2 and 4. So let's find P of 2, so this is A we're working on. It's going to be 2 squared plus 5 times 2 minus 3. So we've got 4 plus 10 minus 3, which gives us 11. And at 4, we've got 4 squared plus 5 times 4 minus 3, 16 plus 20 minus 3 gives us 33. So now we have our X values and our Y values. Let's use our average rate of change formula. The one other thing we might want to note is that our H value is the difference between our X's. So 4 minus 2 gives us 2. So we had a change of X, we had a change of 2. Okay, so now let's plug all these things in. Remember, we're doing P of A plus H minus P of A all over H. So we've got P, our A is 2, our H is 2, and our A is 2 all over H of 2, which tells us we have P of 4 minus P of 2 over 2. So that's what we calculated earlier. P of 4 is 33, P of 2 is 11, and so we end with 11. That is our average rate of change of profit from X equals 2 to X equals 4. Now part B, the instantaneous rate using our 4-step procedure. So the same thing we were doing before. Step 1, P of x plus h. So everywhere we see an x, turn it into x plus h. X plus h squared plus 5, x plus h minus 3. Let's square it. X squared plus 2xh plus h squared. Distribute 5x plus 5h minus 3. I don't see any like terms. Step 2, I want to write f p of x plus h minus p of x. So we'll take what we found out in step 1, and subtract our original p of x. So x squared plus 5x minus 3. I'm going to distribute that first off. And can we cancel anything? X squared minus x squared, 5x minus 5x, negative 3, positive 3. Awesome. 2xh plus h squared plus 5h, which makes step 3 great because we're dividing by h. And so everyone loses an h. 2x plus h plus 5. And then step 4, we take the limit as h goes to 0. So the limit as h goes to 0 of 2x plus h plus 5, if h goes to 0, we're left with 2x plus 5. So we have p prime of x equals 2x plus 5. We found our instantaneous rate equation, which is known as our first derivative. Part C wants p prime of 2. 2 times 2 plus 5, 4 plus 5 equals 9, and an interpretation. So what does this mean in terms of items sold and profit? This means when the second item, because we plugged in a 2 and x represented the item sold, when the second item was sold, the profit was increasing. Remember, this is a rate. Was increasing at a rate of $900 per item. So keep in mind what we're talking about. The 9 is in hundreds of dollars. It's a rate, not a value. So it didn't increase by $900. at the time that we sold the second item, our rate of profit was increasing by $900 per item. Okay, number 5, and our final one for today. The distance of a particle from a fixed point is given by s of t equals t squared plus 5t plus 2, where t is measured in seconds. Find the average velocity from t equals 4 to t equals 6. Find the instantaneous rate of change equation, and use your equation to find the instantaneous rate when t equals 4. Okay, so first, like the last one, we need to know what our y values are at these x values, or what our s values are at these t values. So s of 4, when we have 4 squared, 5 times 4 plus 2, 16 plus 20 plus 2 gives us 38. S of 6, 6 squared plus 5 times 6 plus 2, 36 plus 30 plus 2, 68. And we also should note our h is the difference between our x values, and 6 minus 4 is 2. Okay, so now we want to use s of t plus h minus s of t over h. So we have s of 4 plus 2 minus s of 4 over 2. 4 plus 2 gives us an s of 6 minus s of 4 over 2. And so we have 68 minus 38 over 2, which gives us 15. So our average velocity is 15, whatever it's measuring the distance in, 15 units per second. Okay. B, we'll start with step 1. S of t plus h. So we've got t plus h squared plus 5t plus h plus 2. This is going to give us t squared plus 2th plus h squared plus 5t plus 5h plus 2. Step 2, s of t plus h minus s of t, t squared plus 2th plus h squared plus 5t plus 5h plus 2 minus t squared plus 5t plus 2. So distributing out that negative, minus t squared minus 5t minus 2. Let's eliminate t squared minus t squared, 5t minus 5t, 2 minus 2. 2th plus h squared plus 5h. Step 3. There we go, writing f again. S of t plus h, s of t over h. So we take everything and divide it by our h. Hopefully everybody has an h to cancel out. 2t plus h plus 5. And then let's take the limit h goes to 0. Which is, the limit as h goes to 0 of 2t plus h plus 5. So if h is 0, we're left with 2t plus 5. So we'll write it as s prime of t is 2t plus 5. And so we can use that to calculate s prime of 4. 2 times 4 plus 5 equals 9. And what does that mean? Well, we plugged in t, which is time. And it gave us back what the rate that its distance is changing. So after 4 seconds, the particle's distance is increasing at a rate of 9, and we don't know if it's traveling feet, yards, miles, so we're just going to put units per second because it's not specified. And that's it.